Okay, so what I want to do with you now is to replicate the step one of the building your own circuit exercise. Now, what you can see here on the left-hand side is the diagram that we're going to be using. This is more like the schematic view of what the circuit plan will be. This is step one. The circuit will have a few more parts, but since some of you have never done any such thing before, I would like to just do this one together with you, step by step, slowly, so that we are all on the same page, okay? What we have over here, this is the LDR, the light sensor. Then we have a little resistor, and then we have four little wires, as you can see. I'm going to lay them out on the protoboard and do it slowly so that you can hopefully see. So the first thing I'm going to do is I'm going to unplug my board. When I'm messing around with wires, I like to make sure that my board is not powered, just in case some of the proto wires kind of disconnects itself and ends up short circuiting something. So when I'm working on the electronics, I normally unplug first. And then the first thing I'm going to do is I'm going to get power and ground. So you need, you know, what is called the plus and minus. If you remember from, I don't know, like a battery has a plus and a minus. So just the same, like our microcontroller is going to give us a plus and a minus. The minus is called ground. And we need to get that so that electricity flows through the protoboard. At the moment, it is not flowing at all. Now your board is going to look slightly different from this one. I'm using a different board for this purpose. It's just I don't have the same one you have laying around, but it will look pretty similar. Just make sure that it goes to the correct pins. Now for my ground, what I'm going to do is I'm going to drive the plus or 3.3 volts. I'm going to run them through the red rail, and then the ground I'm going to run it through the blue rail. For the ground I'm going to be using this short blue wire, and then what I do is I locate where the ground pin is indicated as G and D, and then I connect the first pin right next to that one. You see, the first one is connected, the second one is loose at the moment, and I could now choose, depending on how I'm going to lay out the rest of my components, I could choose to kind of come here and connect it there, and then all these holes in this blue rail will be connected now to this pin, or I could choose to just come to this other one, and then it will be these blue ones that are connected to the ground pin. Now which one you choose depends on how you're laying your elements out, but for now I'm going to do it like this. As you can see, the wire is pretty long. We still have, you know, it's mostly slack. In fact, like we could have connected this with a much shorter wire, but when we are prototyping, you know, this is the kind of elements that we use. Once you're done, if you like, you can tape this around and yeah, try to make it a little bit more stable. But for now, all we want is to just make the connections. So right now, from ground to the blue rail, we have already a little wire, and then I'm going to run the next wire, which is from a pin that is indicates 3V3, so 3.3 volts. That's the voltage we're going to be using for our sensors. In my case, it's located here. In your board, it will be somewhere else. You can see it in the diagram. So this is the layout in the Adafruit board. It's quite similar. I think that they are just one pin apart with respect to this other branded board. And then I'm going to again just connect the first pin right there. As you can see, I connect only one pin at a time. I still have the other pin there. And then this one goes to the red rail. Now, make sure that they are not connected to the same rail. Make absolutely sure. this is in the red rail and this is in the blue rail, because if they are connected to the same rail, or they are connected to the same spot, or they become accidentally in contact with each other, so if I let them loose and then I'm messing around and then they accidentally become in contact with each other, what happens if the board is powered via USB is that you will have a short circuit. And you don't want that to happen. You don't want short circuits because, yeah, it might damage your electronics. I mean, it's normally not that heavy to get a short circuit, but something might happen that then becomes really hard to diagnose. So it's better if you spend a bit more time setting up slowly and double checking every connection than ending up with a short circuit that might potentially knock your board out for the rest of the exercise. So there I am. I have now 3.3 volts running through the positive or red rail, and ground running to the negative or blue rail. Okay, so that means that from now on, anything I connect to these two rails, I can get 3.3 volts from any of these holes, and I can get ground from any of these holes. And I need that, I need these for current to flow in any other circuit that I build over here, so that this circuit that I will build over here is connected to the microcontroller, and therefore they can talk to each other. All right. The next element I'm going to lay down is the resistor. I think I showed you that in the other video. I have pretty big fingers, so I like to use tweezers for this job. And we can literally place this resistor. You know what? Actually, I'll correct myself. I will first install the LDR, so the light sensor, because the position of the resistor will depend on this one. So I will first do this one, and then I'll show you how I like to do it. So I'll first straighten the legs a little bit, because I've used this one already a few times, so my legs are a little bit bent. And what I'm going to do now is I'm going to come to this row over here, and I'm going to pick two holes that are a little bit apart from each other. Maybe they have just a hole in between. And at first I'm going to do it quite far away from my board. So yeah, I choose this one. So in my case I chose 7 and 9. So 8 is free, and 7 and 9 have legs in. And you just push down to make sure that it's all the way down. And then what I like to do with this sensor, you will see the reason sometime later, is I like to bend it. So I put it aside like this and I bend it. The reason for this is that, you know, when you're working with proto boards, okay, let me do a better job at this. Yeah, okay. Kind of there. All right. When you're working with proto boards, all the wires kind of stick up. And because light sensors are quite sensitive to shadows and light variations, I like to kind of stick them to the side. So then my interactions will be on the side. Let's say it becomes more like a flute. And then I can turn these around, and you know, that becomes how I interact with this sensor. Or I can occlude it by passing something on top of it. But you will see later, I'll show you later a few, once we have it connected, I'll show you a demonstration of how we could use these potentially for interactions. Now that we have our light sensor down and it's in this row, I'm going to finally connect the resistor. And now the resistor and the light sensor, they're going to have one leg in common. So one of the legs is going to be connected to one of the legs of the resistor is going to be connected to one of the legs of the sensor, and for that we just place it in the same row like this, and then I just basically push it down. All right. So now we have a resistor is inside is already in the board. Let me push it all the way down to make sure that we have a solid connection there. This leg of the resistor is loose. There's nothing connected to it yet. This leg of the resistor is on the same row as one of the legs of my light sensor. So this leg and this leg, they're connected to each other. And the second leg of my light sensor is not connected to anything yet. And that's what we're going to do next. This is basically all we need to sense light. These are all the components we need to sense light from our environment. And I'm now going to wire these to the board and also to the positive and negative so that it becomes functional and we have electricity flowing there, and we can then write the code to do the sensing. So our positive, I'm going to use a orange wire for the positive. So our positive is going to be connected to the second leg of our sensor. So I'm going to connect it here in the same row, and that's going to be our positive. And now, as I said, positive comes from any of these holes along the red rail. So I could do this, and then I'm kind of done with the positive. But because I know that these wires are a bit flimsy, I like to give them a little bit less slack, and maybe just at the expense of maybe stretching them a little bit too far. And that becomes my positive. It doesn't matter which hole you pick, you just pick one. Just try to give yourself some stability here so that you can continue working. And then I'm going to get the negative again from the blue rail, and the negative goes to the first leg of the resistor. All right. So what I do is I pin that one. Whoops. I pin that one there, and then again I bring it to the blue rail, not the red rail, but to the blue rail. I hope that's visible. Let's see. I'm gonna move the cables around so that the camera has a good chance and you have a chance also of seeing it. So now the ground cable comes to the first leg of the resistor. Second leg of the resistor is connected to the first leg of the light sensor, and the second leg of the light sensor is connected to plus, or the red our red rail. So right now this circuit, this little circuit with these two components, will be powered the moment I plug my USB, but we still don't have a means to read our signal. And our signal, I'm going to push this aside a little bit. Now our signal is given to us by the connection between the leg of the sensor, one leg of the sensor, and one leg of the resistor. So we are going to get our signal from there. The signal means that's the reading, the measurement of light from our environment. We're going to get that reading from that leg. So what I'll do is I will use yellow cable for my signal. I will stick the pin in the same row as the other two legs are, so they are all three electrically connected. And then I'm going to take this yellow wire and bring it to pin A4, which in my case is here, and in the diagram it will look slightly different on your board, but the idea is the same. So at this stage of our development, we should have 3 wires coming out of our controller board, one with 3.3 volts going to the red rail, one coming out of the ground pin and going to the blue rail, and one yellow in this case coming out of one analog pin, A4 probably in your case, and going to the place where the light sensor and the resistor meet. I will open this up a little bit so that you can see. So where the light sensor and the resistor meet, this is where I pull out the yellow wire from, and that's it. The other wires, the other long wires over here, are basically just used to get power and ground from the rails and power this part of the circuit. So if everything went well, and I now connect this, I should be able to, from the Arduino environment, write the code that will do the reading of environmental light for this one sensor. And then in part, step 2 of this process is going to be basically replicating this 2 more times, so to have 3 light sensors in total. I will share another schematic with you. You can go to the class notes for that, and then you will have there a schematic with 3 of these sensors. It's basically just replicating the same process. So I will not make a video for that one because yeah, it's basically repeating these 3 times. And then there is another component. I will make another video for that one because there is a little detail about power that I need to explain there. Connecting one third element, which is going to be our servo, but I will meet you there for that one video in another session. Okay, thanks for watching. I hope this helps, and yeah, look at the schematic and try to follow as closely as you can. And I hope you can get this to work. I'll share the code on how to read this sensor next. All right, thanks.